Hello and welcome to the second part of prior knowledge for Unit 1. Okay, just to say, if you are watching this after watching the first part of the prior knowledge section for Unit 1, I've decided to, following these two sessions, what I'm going to do is I'm going to do a deep dive into each of the topics, because I feel like I've skated over them all quite quickly. And part of the purpose of these videos is that it's to allow you to access the higher tier content at school if maybe you're not in a higher tier set, or you might not necessarily be working at that level already. So what I want to do is I'm going to go through the rest of the prior knowledge check for the Unit 1 on the Pearson Edexcel course. And then after that, there'll be some subsequent videos to follow, just to do a deep dive into each one of the topics. So what you might want to do is make a note of which topics you found okay, which topics you didn't find okay, and have a look at the videos that come after this, and I will headline them so that you can see if it's types of number, if it's fractions, if it's decimals, if it's rounding, multiplying and dividing by powers of 10. So don't worry about any of that. If you've been struggling, feel free to just watch this session, take it in, familiarise yourself, have a think about what's going on, and then think about which deep dive sessions you might want to pop into before continuing with the course. Or, as I said, although they've said all of this stuff for prior knowledge, it's not necessarily actually that all of this stuff directly impacts all of the parts of Unit 1 either. So yes, anyway, that's enough for now, and what I'm going to do is I'm going to just get cracking with the rest of the prior knowledge check for Unit 1. Okay, cheers. Okay, so continuing on with the prior knowledge check, the next thing we face to look at is factors, and most specifically highest common factors. So factors are the numbers that you can multiply together to make a specific number. So for example, if I've got if I've got 24, okay, we can make 24 by doing 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so these numbers here are the factors of 24. So if I wrote them in a list, I'd say the factors of 24 are 1, 2, 3, 4, 5, 6, 7, 8. Oh, no, sorry, I just started writing the general numbers there. They're not them, they're 1, 2, 3, 4, 6, 8, 12, 24. Okay, so there we have the factors of 24. Right now then, I just want to write a different number here. I'm going to write down, let's say 18. Okay, right, I'm just going to have a little pause here while you have a look at what's going on the page, and try to have a think about what you think the factors of 18 might be. Okay, so I'll give you 10 seconds for that. Okay, so the factors of 18 are in fact 1 and 18, okay, 2 and 9, 3 and 6, and that's it. So these are the calculations that we can do to make 18. So I know that the factors are going to be 1, 2, 3, 6, 9, 18. Right, now the highest common factor, okay, the highest common factor is the largest factor that is in both lists. So these are the factors of 18, these are the factors of 24. What is the highest common factor? Okay, the highest common factor will be 6. Okay, because 6 is the highest number that appears in both lists. Okay, right, so let's have a look at a different type of question then. Okay, and this one is for the lowest common multiple. Okay, so let me write this down, sorry about that. Right, so the lowest common multiple. Okay, right, so this here, the term multiple essentially refers to the number that are in its times tables. So e.g. multiples of 3 would be 3, 6, 9, 12, 15, 18, 21. So if you see each one of these, we're increasing into 3. So this is 1 times 3, 2 times 3, 3 times 3, 4 times 3, 5 times 3, 6 times 3, 7 times 3. Okay. I'm going to put here e.g. multiples of 5. Multiples of 5. Okay. And if you want to take a brief moment to think about what you think the multiples of 5 might be, I'll give you 10 seconds and then I'll write them down. Okay, so the multiples of 5, as you might have guessed, are 5, 10, 15, 20, 25, 30, and we'll just continue in the 5 times table. Okay, so if you don't know your times tables, it is beneficial to try to learn them. There's not very many exciting ways of trying to learn them, I'm afraid, but it's good just to practice them, go over them, and go from there. I mean, one large benefit in maths is that we have our calculator, and with the maths GCSE, there's 2 papers which are calculator based and 1 paper that isn't, okay? So for the 1 paper that isn't, it is important to know them, but having a calculator, if you get your calculator, this one's a good one to use, the Class Whiz, you can just test it. So I could say, okay, what's 5 times 8? I'll type in 5 times 8. 5 times 8 is 40. Press equals. Is that 40? Yeah, okay. And so you can just do that and check. What about 6 times 2? 2. 12, is it right? Yeah, okay. 7 times 8. I think that's one of the hardest ones. 7 times 8. Well, I know that 7 times 7 is 49, so 7 times 8 will be 56. Let's see. Yeah, 56, okay. But, yeah, so anyway, back to this, lowest common multiple. So we have our multiples of 3, we have our multiples of 5, okay? And we're looking for the lowest common multiple. So that's now, this time, looking for the lowest number that appears in both of these lists. Okay, so let's have a look at this one first, because the 5 times table is easy to spot because things end in 5 or 0. So the first number that ends in 5 or 0, here we go, 15 and 15, okay? So we've got the lowest common multiple, LCM, of 3 and 5 equals 15. which in this circumstance, coincidentally, is 3 times 5. Okay, great. We'll do more on that later, actually. But yeah, if that makes sense to you, that's good. This is important usually for adding fractions, because when we look at getting a common denominator, we're often looking to use the lowest common multiple in order to keep things nice and simple. Right, the next questions that they've got on here are about Bidmass, okay? Bidmass, or Bidmass, some people call it. Okay, and this stands for, I'll write it out here, I should have written these down really, but it stands for brackets, okay, indices. I'm going to use Bidmass because we use the term indices a lot in maths and we don't ever really use the term order, which is what they use the O. Divide, multiply, add, subtract. Okay, and this is basically the order that we have to do things in maths. So let me just turn that slightly. Okay, so say for example I had a question which was 6 minus 5 times 1. Okay, so I mean, I've actually made a question that doesn't really matter which way around we do it, but the fact is for this one, if we look here, we look down the list for the things that we've got 2 operations here. We've got take away and we've got times. Look down this list, right, multiply, that's times, multiply comes first. So the first thing we'd do 5 times, minus 5 times 1, which is minus 5. So we'd get 6 minus 5, okay, and then we'd just do 6 minus 5, which we know is 1. Okay, let's have a look at another. Let's say I had 7 minus 2 times, actually let's say 7 plus 2 times 4. Okay, so we've got 7 plus 2 times 4. Well, we do the 2 times 4 first because that's what comes first. So 2 times 4 is 8. So then we've got 7 plus 8, and 7 plus 8 is 15. Okay, right, so I'm going to put another example here for you to have a think about. Just with like these simple things again, let's have 10 minus 3 times 2. Okay, so have a think about this. Remember what you're doing first. I'll give you some moments. Okay, right, so the way that you should have gone with this was we should have done the multiplication first. So 3 times 2 is 6. So we end up with 10 minus 6. Okay, and 10 minus 6 equals 4. Okay, right. Let's incorporate a few more things. Okay, so I'm just going to move down here. Let's have a look at incorporating. I'm going to extend this line over here just to make more use of the paper. So let's have a use at incorporating brackets this time. So this time I've got 5 plus 2 bracketed all times 3. Okay, right, so if we look down the list, brackets indicates what we do first. First of all, we have to sort out the bracket, because once there's something going on inside a bracket, that bracket takes on the value of what's going on. So this isn't actually, if we were reading this, we've got to acknowledge this 5 plus 2 first. So the 5 plus 2 is 7. So actually this bracket indicates that this expression, this sum, is actually 7 times 3. So we'll do 7 times 3, and that equals 21. Okay, let's make it a little bit longer. Let's have here, I'll put a line just to divide it off. Let's have 4 plus bracket 2 times 5 times 2. Okay, right, so let's have a look down the list. Brackets first. Okay, so the bracket first, so we've got to do this 2 times 5. I mean, to be honest with you, we would have actually done the 2 times 5 to start off with anyway there, so it doesn't make too much difference in this case, but I've put the brackets here, so I'll do that first. So we've got 4 plus 10 times 2, okay, and then multiply next. So 10 times 2 is 20, so 4 plus 20, okay, and we know that that equals 24. Okay, so let's have a look at another one. Let's have a look at, okay, let's have 3 plus 1 squared divided by 2. Okay, and then let's put something else in there just to mix it up. Plus 5. Okay, right, so we've got here 3 plus 1, which we've got to do first. 3 plus 1 gives us 4, okay? So I'm going to put 4 there, and we've got squared, okay? Divided by 2, plus 5. Okay, so this 2 is still linked to that 4, okay? We can see that that 2 looks closer to that 4 or anything else, but that 2 is what we call an indice, okay? And the number, an indice that's in your, they're always on the top right of the number. They dictate how many times that number is being multiplied by itself. So for here we've got 4 to the power of 2, which we often call 4 squared. So 4 to the power of 2, this means 4 multiplied by 4, okay? And if you had your calculator as well, you could check that. So 4, and we put that here, and you'll see that there's this little button here, which says x2. I mean, if I push that up there, we get that. And if we press equals, we can see that that's 16, which makes sense because 4 times 4 is 16, okay? So let's put that down. So 4 times 4 is 16, okay? Then we've got the divide 2 and the plus 5. Look down the list, the next thing that happens is the divide, okay? So 16 divided by 2 is 8, so we get 8 plus 5, and then that equals 13. Great. Okay. Right, I've got a bit of space here, so I'm just going to write down another question, okay, for you to have a go at by yourself. Okay. So let's put this here, and let's have similar to that. Let's have this time. Let's have 20 divided by 5 minus 1. No, 5 minus 3 is what I meant to say. 5 minus 3 squared. Okay. So I'll give you some time to think about that. I'll give you about 10 seconds, and then I'm going to jump in. Okay, so first of all, we want the bracket. So we've got 5 take away 3. So we're going to have 20 divided by, oh, let me just shuffle that down a very small amount. 20 divided by 2 squared. Okay, well, we know that 2 squared is 2 times 2. Okay, so 2 times 2 is 4. So what we're actually looking at, I'm going to use a bit of weird notation here. I'm just going to put an arrow. That's not official maths. I'm just saying that this is where we're going. But this gives us 20 divided by 4, because 2 squared is 4. So 20 divided by 2 squared is exactly the same as saying 20 divided by 4. Okay, and we know that 20 divided by 4, if we count up in 4s, 4, 8, 12, 16, 20. 20 divided by 4 is 5. Okay, so here we go. We've got 20 divided by 4 equals 5. Right, again, if you want more work on that, you can access the deep dive session. Okay, and that will help you out there. So let's have a look at the next thing that we've got on this list. Okay, right. So they've got a section here where they're still on Bidmass actually, and it's a Bidmass question where you've got to insert your own brackets, okay, to make sense of a situation. So I'm going to have 10 plus 15 divided by 3, and I'm going to say that this equals actually, sorry, I'm going to say divided by 5. Okay, sorry about that. I'm going to adjust that question. Okay, so 10 plus 15 divided by 5 equals 5. Okay, and the question is to place brackets to make it right. Okay, so I mean, there's only 3 numbers here, so we're going to place the brackets in one of 2 ways, really. We're either going to place it round the 10 and the 15, or round the 15 and the 5. Okay, so let's have a look at. Well, I know which is the wrong one, so I'm going to look at the wrong one first. Okay, so let's say we placed it round the 15 and the 5. First of all, we don't actually need to do that because we do divide first before add. So whatever the case was, if there was no brackets, this would be the bit that comes first. But if we look at 15 divided by 5, 15 divided by 5 is 3. Okay, so we'd then be looking at 10 plus 3, which we all know equals 13. Okay, so we know that the brackets don't go around the 10, the 15 and the 5. So I'm just going to put a big cross next to that. Okay, and so that means that the brackets are going to go round the 10 and the 15. So I'm going to put them in now, and let's analyze this. So 10 plus 15 equals 25. So we've got 25 divided by 5, and that equals 5. So that makes that correct. Okay, let me slide down here and let's have a go at another one of these, and let's say this time I'll make it a little bit longer. Let's say I've got 6 plus 3 times 4 minus 1 equals 15. Okay, so 6 plus 3 times 4 minus 1 equals 15. Okay, so I'll leave you 10 seconds to think about that, and then I'll jump in. Okay, by the way, if you do need any more than 10 seconds, feel free to pause the video and have a go if you wanted to write things down, or if you're happy just having a look, seeing if you can guess. This is like the prior knowledge check. So let's have a go. So let's have a look at the different places we could put them. We could put them round the 6 and the 3, which would make that a 9, okay? And then we could put them round the 4 and the minus 1, okay? So let's first of all say we put them around the 6 and the 3. So that would give us 9 times 4, which would be 36. Take away 1 would be 35. So it's not that. So I'll write that down below just so actually we can see what we're eliminating. Okay, I'll move that down here. So we're saying that if we had it round here, 6 plus 3 times 4 minus 1, that would equal 35. Because 6 plus 3 is 9, times it by the 4 because we do multiply next. Okay, that would give us 36, and then take away 1 would equal 35. Okay, so it's not that. Let's have a look at a different option then. So we could put them round the 4 and the 1. Okay, I'm skipping the 3 times the 4 because at the moment, if we were to put them around the 3 and the 4, it wouldn't actually make any difference, okay? Out of interest, maybe what we should also do is first check the sum. So if I was going to calculate this sum, currently, let's have a look. So we've got 3 times 4 is 12. So we'd have 6 add 12 is 18. Take away 1 is 17. So currently, this has 17. So let's try the last brackets anyway. So let's go 6 plus 3 times 4, take away 1, bracket, bracket, equals 15. Okay, so we've got here, we've got the 2, we can do the bracket first. So we've got 6 plus 3 times 3. Okay, then we do the multiply. So we've got 6 plus 9. Okay, and 6 plus 9 actually does equal 15. So we've got our solution. The brackets went round the 4 and the 1. So if you worked that out, congratulations and well done. Okay, the next question we've got is we've got estimating. Okay, so estimating is when we look at complicated sums and we make them simple and we decide what we're going to do. So if I've got here, estimate the following. Oh, let me move up a little bit. Estimate the following. Okay, so the first one we've got here, we've got 3.9 plus 2.7. Okay, so when you estimate, you just look at what the number roughly is. So this number is roughly 4, and this number is roughly 3. So the answer would be roughly 7. Okay, now if we wanted to adjust the answer, we could see that this is 0.1 less than 4, and this is 0.3 less. So actually the answer would be less than 7, and it would be 0.4 less, so it would be 6.6, okay? But this is the estimation, okay? And that's just what the answer really would be, okay? Let's have another go at another one. Let's call this question A. Let's have a look at B. So we could have 10.3 times 2. I don't know, let's have 2.8. Okay, right, 10.3 is roughly 10. Okay, 2.8 is roughly 3. Okay, and here we know that this answer would be roughly 30. Okay, it's an estimate, so we don't have to be too convinced. Okay, interestingly, what we did here was we might want, if you watch the prior knowledge part 1, okay, when we round, we look at the numbers and we decide if the number's 5 or above, 6, 7, 8, 9, we give it a shove. So in this case, 2.8 is clearly closer to 3 because 8 is 5 or above. 10.3 is clearly closer to 10. Okay, let's have a look at another one. Okay, let's say this one here, C. Let's have 19.4 times divided by, actually let's go for divide by 10.1. Okay, So 19.4 is a bit different here because we've got a 3-digit number, okay? I'm going to turn it into 20. Now, the reason I'm going to turn it into 20 is because it is roughly 20, even though it wouldn't technically round to 20. Well, it would round to 20 to one significant figure, but first of all, it'd round to 19 before that, and then it would round to 20. But I'm going to turn it to 20 because I can see that this second number goes really close to 10. So 20 divides by 10 very easily, and that would be 2. Okay, great. So the next section that we've got on this, okay, is square numbers, okay? So square numbers. And square roots. Okay, so square numbers are relatively straightforward. They're basically based around if you were making blocks, if you were making squares out of blocks, okay, what numbers would you get? Like how many blocks would you get there? Okay, so this one, the first square number, 1, goes to 1, okay? The second number, 2, goes to 4. If we think about this being the first square number, this being the second, this being the third, okay? Okay, the square numbers relate to if these were squares, okay? So the third square that you could make is 9, okay? And the fourth square you can make is 16, okay? And you're essentially getting these by doing 1 times 1, 2 times 2, 3 times 3, 4 times 4. Okay, so these are the first. So when we look at these, we would call this the square number. Okay, so these are the square numbers, and these are the square roots. Okay, so these are the roots because it's the roots that the square number came from. So this square number appeared because 1 times 1 makes 1. This square number, 4, appeared as a square number because 2 times 2, if we look up here, 2 times 2 gives us 4. Okay, and this one here, 9, is the square number because 3 times 3, okay, gives us 9. Okay, so these are square numbers. We can also, there's some terminology that you should use here. Okay, so you essentially get your square number, okay, and this is what we were looking at a little bit earlier, by squaring a number. So for example, we've got 1 squared equals 1 times 1 equals 1. Okay, 2 squared equals 2 times 2 equals 4. Okay, 3 squared, okay, so that's to the power of 2, equals 3 times 3 equals 9. 4 squared equals 4 times 4 equals 16. 5 squared equals 5 times 5 equals 25. 6 squared equals 6 times 6 equals 36. Okay, I'm going to use this here as well. I'm going to continue because you're required to know up until 12 squared. So I'm going to write all of these down. I don't expect you to write them down as well right now, but just know that they're worthwhile remembering and they will help you out in the future. So we've got 7 squared is 49. 8 squared is 8 times 8 equals 64. Okay, let's just shuffle over there. 9 squared equals 9 times 9 equals 81. 10 squared equals 10 times 10 equals 100. 11 squared equals 11 times 11 equals 121. And 12 squared equals 12 times 12 equals 144. Okay, so I'm going to just ask some quick questions here now. I'll go through the first one, but then I'm going to leave some time between them so that you can have a think about these. So, first of all, I just want to clarify, these are the square numbers. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. If I asked you what the fifth square number was, the answer would be 25, because 5 squared is 25. If I asked you what the seventh square number was, the answer would be 49, because 7 squared is 49. If I asked you what the 10th square number was, okay, have a think. The answer would be 100, okay? Have a go at identifying the third square number. Okay, the answer is 9. Have a go at identifying the 8th square number. The answer is 64. Okay. How many square numbers are there between 20 and 30? Okay, so what I meant was that here, if we look between 20 and 30, there's only 25. So there's one square number between 20 and 30. How many square numbers are there under 50? So we can look up the list here. We've got 1, 2, 3, 4, 5, 6, 7 square numbers under 50. Okay. Right, okay. So that's square numbers. Now I want to look at the term square roots. Okay. So the square root sign is written like this. This is the square root sign. And that is, as we discussed earlier, the number that takes you back to where the square number came from. Okay, so if I put here, I've got the square root. If I said, what's the square root of 36? Okay, we can look down the list. Here's 36. So 36 came from 6 squared. So the square root of 36 is 6. Okay. What is the square root of 64? Okay, have a look. Okay, the square root of 64 is 8, because we can see here that 8 times 8 is 64. Okay, what is the square root of 144? Okay. Have a look at the list. Right, the square root of 144 is here, it's 12. Okay, and let's do one more, and I've got a little bit of space here. Let's have the square root of 1. Okay, so what is the square root of 1? Have a look at the list. Okay, here we go. Here's 1. The square root of 1 is 1. Okay. Here's a question to pose that requires some extra thought, okay? So I'm going to just move over here a little bit more, okay, so that we're just focusing on the square numbers, okay? So this is going to use some you to think a little bit about this, but I'm going to say, what 2 integers integers are either side of the square root of 10. Okay? And when I mean that, when I say that, I'm saying, what is the integer that's smaller than the square root of 10? And what is the integer that's larger than the square root of 10? Okay? So, if we look here, well, I'll leave you to have a short think about that. But it's a bit of a leap. So don't worry if you can't work it out. But well done if you can. Okay, so if I look down here, I'm looking at the square numbers. Okay, we've got 1, we've got 4, we've got 9, we've got 16. Okay, 10 isn't a square number. So it doesn't technically have a whole square root. Okay, so there's no nice number that multiplies by itself to make 10. But what we do know is we've got here the square root of 9 and we've got the square root of 16. Okay, so the square root of 9 is 3 and the square root of 16 is 4. So if we were looking for what two integers are either side of the square root of 10, the answers would be 3 and 4. And let's examine that on the calculator. So on your calculator, you'll have a square root button, okay? So this button here can find out the square root of any number, regardless of whether or not it's a square number. So I've pushed that button there, and then I'm going to enter 10 in this little box. So 10 inside that box. And now what I'm going to do is I'm going to push equals, and it's just going to give me root 10. And then I'm going to push this button here, S to D, and that's going to turn it into 3.162. So the square root of 10 equals 3.162 to 3 decimal places. Okay, let's move that. And that makes sense, okay? So what two integers are either side of the square root of 10? 3 and 4, and that's correct because the square root of 10 is 3.162 to 3 decimal places. Okay, great. So the next thing that we've got to do on this list is largely just indices, okay? And it's very straightforward with indices. It just wants you to know what the indice refers to. So we've already covered this a little bit. So let's say if I had here 3 times 3 times 3 times 3 times 3, I would write this as 3 to the power of 1, 2, 3, 4, 5. Okay? Because I'm multiplying 3 together 5 times. If I said what is 4 times 4, okay, this would be 4 to the power of 2, as I'm multiplying 4 together twice. So this number indicates how many times I'm multiplying something by itself. Okay, if I had 10 times 10 times 10, this would be 10 to the power of 3, because I've multiplied 10 by itself 3 times. Okay, if I had here 7 times 7 times 7 times 7, okay, take a moment and think, how could we rewrite this using index notation, so using an indice? Okay, hopefully you got that. So that would have been 7 to the power of 4. So we're also required to be able to know this in reverse. So let me just leave this information here. And I want you to have a think if you could work out, okay, what, for example, 2 to the power of 6 would be. I don't necessarily want you to work it out, I just want you to know what calculation you'd do to get 2 to the power of 6, to find out the value of that. Okay, so I'll leave you some seconds to have a think. Okay, and so here we go, that's going to be 2 times 2 times 2 times 2 times 2 times 2. Okay, 1, 2, 3, 4, 5, 6. And that equals, I can work that out on my calculator. I'm going to use this button here this time actually. So I'm going to type 2, so you can see I've got 2. And then if you look up on your ClassWiz calculator, you'll have this button here, X, with a little square. Okay, if you push that, you can see the flashing square that goes in the top right corner of the number, and we can put there the number that we're looking at the power of. So we've got here 2 to the power of 6. So I push that, and I can see that this is equal to 64. Okay, great. Let's have a go at another one. 7 to the power of 3. Okay, so have a think what that would equal. And if you've got your calculator to hand, you can have a go. If not, as long as you know how you'd work it out, that's perfectly good as well. Okay, so hopefully you'll have known that 7 times 7 times 7. And let's have a look. Okay, I can do this either way. I can do 7 bracket indices sign to the power of 3 and see that this is equal to 340, or 400, yeah, 343. Okay, right, and let's just do one more. Let's have 5, let's go to the power of 9 because I'm using the calculator. So think about how you would work that out. If you've got your calculator, have a go at working it out. This is a little bit too large to work out without a calculator. I mean, I'm sure you could do it if you'd wanted to, but it would just take a lot of time. So let's have a look. I think we've got here, let's have 5 times 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5, 6, times 5 times 5 times 5. So I've got 5 times by itself, 9 times. Then using my calculator, 5 to the power of 9 equals, here we go, 1, 9, 5, 3, 1, 2, 5. Okay, great. So that there is everything covered from the prior check, the prior knowledge check. But remember, if you did struggle with everything, I'm going to put some deep dive videos in for each topic, which will be a lot shorter than these and should allow you to cover that. So, yeah, 1 second, I will just flip around and say goodbye. Okay, right, yeah, so thank you very much for watching. I hope that was helpful for you. Oh, actually, what I will do is I'm going to quickly, well, I'll put up a page of questions that revisits what we just looked at. And then I will put up a page of answers if you want to have a go at that again just now. Okay, cool. So I'm going to sign out from here and hopefully I will see you in another video, or you'll see me, or whatever. And if you have any questions, any comments, please leave them below. And yeah, okay, thank you very much. Goodbye.